7.5 Operations with matrices. What we should learn: decide whether two matrices are equal, add or subtract matrices, and multiply matrices by scalars. Multiply two matrices, and then use matrix operations to model real-life problems. The last lesson we used matrices to solve systems linear equations. Now we're just going to talk about how to work with matrices in general. You can represent a matrix by using capital letters. That's what we usually do. You can also represent an element of the matrix by letting us know what row and column it is. You want this element right there. You can say lowercase matrix A, lowercase 1, 2, so we know it's that element. Equality matrix. If two matrices are equal, that means that all the elements are equal. A11 would be 2. A12 would be -1. A21, -3. And A22, 0. If two matrices are equal, all the corresponding parts are equal. Matrix addition and scalar multiplication. We're going to talk about how to add and multiply matrix. Anytime you hear scalar, that's just a number. We're saying we're going to multiply this matrix by a number. Instead of multiplying two matrices together, we're going to multiply a number by a matrix. Let's do a couple examples here. So the way you add matrices is at the match, you just add up to the corresponding part. If I was to add these two matrices, I'll add -1 to 1, 2 to 3, 0 to -1, and 1 to 2. We would get 0, 5, -1, and 3. Likewise over here, you're like, okay, just add up the corresponding parts. So 0, 0, 0. Now if I want to add up these next two, I can't because this guy has no one to add with. 2 would add with 0, 1 would go with 1, but this one's missing. That's why you can't add matrices that don't match. It's not possible. Okay, let's talk about scalar multiplication. Like I said before, scalar is just a number. We multiply a matrix by a scalar number here, 3a. Here's my matrix A, let's times it by 3. Multiply every element by 3. If I wanted 3a here, I have to multiply everything by 3. It becomes 6, 6, 12, -9, 0, -3, 6, 3, and 6. That is scalar multiplication. Let's copy it down real quick. And now we want to subtract b. This is doing a lot of math problems all at once. Something to that effect. And then you just subtract the corresponding parts. If they match, subtract the corresponding parts. We get 4, 6, 12, -10, -9 minus 1, +4, 0 minus -4, -6. Remember, we are subtracting. You can also multiply all these by -1 if you want and just add them up. But 6 minus -1 is a 7. And then we got 0, and this was a 6. 6 minus 2 is 4. That'll be our solution there. Here's some properties of matrix addition and scalar multiplication. First of all, when you add matrices, it is commutative. You can also do the associative property. And then there's some other formulas. You add to 0, 0 matrix, this right here, the 0 matrix, this is a matrix all zeros. It could be this, it could be a 2 by 2. Any type of matrix with all zeros is a 0 matrix, and so on. When you do the distribution property, we're going to multiply everything by 3. First, let's add the parentheses. I would get 2, -2, 7, and 8. And now we distribute everything by 3. We get 6, -6, 21, and 24. Solving a matrix equation. So let's say we have this. We have 3 times x plus matrix A, 1, -2, 0, 3 equals matrix B, -3, 4, 2, 1. If we want to solve for this, all we're going to do is do like normal, subtract this from both sides. So we're going to subtract this matrix from both sides. Now when you do that, it goes over here, and we get 3x is equal to -4, 6, 2, -2. Man, you really get good at adding, subtracting negatives when you see this. -3 minus 1 is -4. 4 minus -2. 2 negatives make a +6. Then how do you solve this? Well, multiply by the reciprocal of 3. So we're going to multiply both sides by the reciprocal of 3. And that's how you distribute. You're going to get -4/3, 2, 2/3, and -2/3. And that'll be our solution. It's like solving like normal, just using matrices. Let's talk about matrix multiplication. The first thing about matrix multiplication is it is not just multiplying corresponding parts. No. It's not just going to be A, C, B, D. That's not how it works. In reality, you actually can't even multiply these so that they don't match. When we multiply matrices, we multiply the rows of the first times the columns of the second matrix. We have to actually make sure we can match. That's where you see this little thing here. When you multiply matrices, row by column, we have to make sure the columns of the first match the rows of the second. That's when they show this little thing here. If it's m times n and n times p, these must match. And then your resulting matrix is going to be the outside. You're going to get an m times p matrix. When we multiply matrices, make sure they match. The one we did here would not match. This is a 2 by 1 times a 2 by 1. These do not match. I cannot multiply these two together. Multiplying matrices is different than you think it is. You have to multiply rows of the first times columns of the second. Let's multiply these two real quick to see how it's going. First, let's see if you can. This is a 3 by 2. This is a 2 by 2. Yes, they do match. A little smiley face. I can multiply them, and we're going to get a 3 by 2. One thing we can do is just write a big old matrix here. Multiply this guy by this guy. -1, 3, 4, -2, 5, 0, -3, 2, -4, 1. And we're going to get a 3 by 2. Let's write a 3 by 2. We have 3 rows. This is row 1, row 2, row 3. And these are 2 columns, column 1, column 2. The key is it's rows of the first. That's my first row. It's my second row. And my third row. Times columns of the second. My columns go up and down. Column 1, column 2. And really, it's just bingo or battleship. If I want to figure out what this one is right here, this entry is row 1, column 1. So we're going to multiply row 1 times column 1. Now the way it works is you multiply the first 2 entries, -1 times -3. And then you add it to multiply the next 2 entries, 3 times -4. We're going to get 3 minus 12, which is -9. And that's it. When I move on to the one right here, this is row 1, column 2. Multiply the first 2, -2. Add it to the next 2. 3 times 1, 3. So I get 1. And then move on. Row 2, column 1. Row 2 times column 1. I get -12 plus 8. That's -4. And then row 2, column 2. Row 2 times column 2 is 8 plus -2, 6. And then likewise, column 1, row 3. Let's actually do that one. This one right here is row 3 times column 1, -15 plus 0, or just -15. And then column 2 times row 3. Row 3 times column 2 would be 10 plus 0, which is 10. And then that is our answer. Let's rewrite it. -9, 1, -4, 6, -15, and 10. When we multiply, first check if you can multiply it. Then you get your resultant matrix. Write that out. And then just go give rows of the first times columns of the second and just match it up all the way through. Let's do another one here. And then this one I'll show you the shortcut. There's a slight shortcut. First, let's check 2 by 2 times a 2 by 2. So that does match. And we're going to get a 2 by 2. Here's a slight shortcut to this. I'm going to write one right here. And then we're going to write the second one above it to the right. Instead of writing it right next to it, we're going to write it up here. 1, 0, 0, 1. And then we're going to get a 2 by 2, but we're going to do this. We're going to separate this with a line between those 2 marks, and a line between these 2. And here's our 2 by 2. So if I want this entry right here, it's going to be this row times this column. 3 times 1 is 3, plus 4 times 0, which is 0. So just 3. You go on to this one. 3 times 0 is 0, plus 4. This one down here, -2 times 1 is -2, plus 0. And then the one right here, this row times this column, 0 plus 5. We get 3, 4, -2, 5. That's a little bit of the shortcut. You're still doing the same thing, multiplying rows and columns, but this makes it a little cleaner, a little easier. If you notice we get the exact same answer that we start off with, that's because this is what's known as an identity matrix. We'll talk more about that in the future. It's like multiplying by 1. You should get the same thing back. Let's do another one real quick. First, let's check if we can. This is a 3 by 3, and this is a 3 by 1. Yes, we can multiply these two. And we're going to get a 3 by 1. Again, I'm just going to do this trick real quick. 6, 2, 0, 3, -1, 2, 1, 4, 6. And then this is going to be 1, 2, 3. And we're going to do the exact same thing. Put a line through here, a line through here. Now there's nowhere to put a line, but that's our 3 by 1. 3 rows, 1 column. That's our space. And all we can do is the same thing. We're going to multiply the first 2 together. 1 times 6, plus multiply the next 2, 2 times 2, plus 0 times 3. That's going to give me 6 plus 4 plus 0. My first answer is 10. I'm just sending the second row. This one times that. 3 plus -2 plus 6. We get 7. And the bottom one, 1 times 1 is 1, plus 4 times 2 is 8, plus 6 times 3 is 18. I get 20, what is that, 9, 27. And there we go. Sometimes you cannot multiply them. This one here, this is a 3 by 2. And this is a 3 by 4. And thankfully we cannot multiply these two because these do not match. No solution. Or no product. Now let's talk about how you can do this on your calc. Let's bring it over first. We're going to enter these matrices into our calculator and go second matrix. I can reselect it. I already have something in matrix A, but honestly, the easiest way to do it is just right over it. Go to edit. This is a 2 by 3. 2 by 3. and type in entries 1, 2, 3, 2, -5, and 1. Then let's get out of this one. Go back to our matrix. So now our A is a 2 by 3 now. Go over this one. Go to B, make it a 3 by 3, and enter in all the values. -3, 2, 1, 4, -2, 0, 1, 2, 3. Okay, so we can get out, and we want to multiply A times B. Now keep in mind, A is a 2 by 3, and B is a 3 by 3. We should be able to multiply them, and we should get the 2 by 3 as our answer. All we're going to do is go back to our matrix and select it. That's what this column is for. And times it by the matrix, and we get our answer. Yes, the whole point of using matrices is to make our life a little easier. If you have it in a matrix, you could put it into a calculator or a computer. There's that answer. By the way, if you do B times A, those do not match, and I should not be able to multiply them. Let's just try that real quick. If we go second matrix B, and then we times that by matrix A, I get the error dimension mismatch. So you cannot do these two. Not possible. That's the cool thing about matrices. They're not commutative, unlike most multiplication is. AB does not equal BA. Here's some properties that do work with matrix multiplication. If you have 3 matrices, it is associative. You can also do the distribute property on the left-hand side or the right-hand side. Keep in mind, it's the left or right. If you multiply on the left, you have to multiply on the left on this side. Those things do work, but it is not commutative. AB does not equal BA. Okay, let's finish off by doing an application problem. How we can use matrices in real-world applications. The 2 softball teams submit equipment lists to their sponsors, as shown in the table below. The women's team has this, men's team has that. Equipment costs are follows. Bats cost $90, ball 6, and gloves 60. Use the matrix to find the total cost for each team. Let's put this data into a matrix. Put a matrix right here. This is women's teams. This is a men's team. We have bats, balls, and gloves. We have 12, 15, 45, 38, 15, and 17. And then here's our cost. Notice how it's bat, balls, and gloves. So we want this to match this. This is a 3 by 2. This is one set of information. It's bat, balls, gloves, and how much they cost. We have either a 1 by 3 or a 3 by 1. I could write this 96, 60. That'll be a 3 by 1. Or I could write it sideways 96, 60, and this would be a 1 by 3. I want bat, balls, and gloves. That's the row here. I want to be able to multiply this guy by one of these. They can actually multiply and get an answer. Actually, I'm going to have to write it this way, because this, bat, ball, and gloves, remember when you multiply matrices, you want the inside two to match. So I'm going to write it this way. We can multiply our 1 by 3 matrix by our 3 by 2 matrix. And then these guys will match, and I would get a 1 by 2. So I'm going to write our 1 by 3 here. This is cost. Bat, ball, gloves is 96 and 60. I'm going to multiply that by this guy here, like that. This is a 1 by 3. This is a 3 by 2. On the end of this, we're going to get a 1 by 2. And that 1 by 2, by the way, is cost. Because notice how this guy is match with this guy. And what's the 2? The women's team and the men's team. That's the way it works. You want to make sure they line up, they actually multiply them. And then the row of the first one is going to be the column of the second one. Then we just multiply this out. And that you use a calculator for. Second matrix, clear out of that. Second matrix. Again, easier just to write over it. I want a 1 by 3. And it is 96 and 60. So then go back to matrices, go my edit, go B, and we want that to be a 3 by 2. 12, 15 is fine. It should be 45, 38, 15, 17. Okay, and enter, make sure I hit that one. Then we're just going to multiply those two. We'll multiply by matrix A times by matrix B. By the way, you know that multiply, it's implied. I get the cost. 2250. 2598. That's the cost for each team. Women's teams cost that, and the men's teams cost this. That's matrices in a nutshell.